Yes, we got a new data and information from James Webb Telescope concerning a specific system, and this system is quite similar to our own solar system because they are all in our galaxy, the Milky Way galaxy. And this particular system has been under investigation because it's quite similar to our solar system in not only in terms of how its contents of planets actually are aligned, but most importantly, what are the characteristics between these particular exoplanets in this particular system and its own red dwarf, that is its own star. And so this here focuses on one particular exoplanet that is rocky in nature, and its name is TRAPPIST 1c. And this here, according to James Webb Telescope, is able to provide us with an interesting information about its atmosphere, specifically this particular rocky exoplanet TRAPPIST 1c. And its exoplanet is considered to not have a thick atmosphere, which is a characteristic of a gas that is called carbon dioxide, but rather it has a thin atmosphere. And this here is one of those interesting information that is quite interesting based on this particular exoplanet and how it is a little bit similar to our own particular solar system planet, which is known as Venus, because this exoplanet has the same roughly size as our Venus planet, and also it receives some specific amount of energy from its own sun, specifically the red dwarf TRAPPIST, alongside that same amount as Venus received from our own sun. And so this emission of energy that is released by this exoplanet really shows that James Webb is able to capture the type of atmosphere that this TRAPPIST 1c planet has, and carbon dioxide is not really a promising thing for this exoplanet. Now, this here also shows some interesting results regarding how this atmosphere and James Webb Telescope is really powerful in analyzing some specific characteristics of atmosphere. This opens the door for detection of oxygen, nitrogen, and of course in this case here we have carbon dioxide. So really promising to see how James Webb is able to capitalize on its particular tools and also collaboration with other tools to enable us to get a rich information about not only exoplanets that are within our specific galaxy, but maybe outside our galaxy. And so looking at this article, it says that TRAPPIST 1c is one of the 7 rocky planets orbiting an ultra cold red dwarf star, or called M dwarf. Now this here is 40 light years from Earth, although the planets are similar in size and mass to the inner rocky planets in our own solar system. It is not clear whether they do in fact have similar atmosphere. Now, during the first billion years of their lives, M dwarf emits bright X-rays and ultraviolet radiation that can easily strip away a young planetary atmosphere. In addition, there may or may not have been enough water, carbon dioxide, and other volatile available to make substantial atmospheres where the planet formed. Now, to address these questions, the team used the MIRI Webb mid-infrared instrument to obtain the TRAPPIST-1 system on 4 separate occasions as the planet moved behind its star, a phenomenon known as secondary eclipse, which is similar to what we talked about on our previous video, by comparing the brightness when the planet is behind the star, starlight only, to the brightness when this planet is beside the star, where light from the star and planet combine. Now, this team was able to calculate the amount of mid-infrared light with wavelength of 15 microns given off by the day side of the planet. Now, this method is the same as that used in other research for TRAPPIST-1b. And this innermost planet in the system is probably devoid of any form of atmosphere. Now, the amount of mid-infrared light emitted by a planet is directly related to its temperature, which is in turn influenced by atmosphere. Carbon dioxide gas preferably absorbs 15 microns in light, making the planet appear dimmer in that wavelength. However, clouds can reflect light, making the planet appear brighter and masking the presence of carbon dioxide. Because TRAPPIST-1c orbits so close to its star, it is thought to be locked, with one side in daylight and the other in endless darkness. Now, the data is also shown that it is unlikely the planet is a true Venus analog with a thick carbon dioxide atmosphere and sulfuric acid cloud. Now, the absence of a thick atmosphere suggests that the planet may have formed with relatively little water. If the cooler, more temperate TRAPPIST-1 planet formed under similar conditions, they too may have started with little of the water and other components necessary to make planet habitable. The decrease in the brightness that James Webb detected during a secondary eclipse was just 0.04%. That's equivalent to looking at a display of 10,000 thin light bulbs and noticing that just 4 have gone out. Now, there's another graph that actually shows the relationship between the brightness of light emitted by the planet and the wavelength of light. And there are 3 graphs here that are on this particular grid, and one shows a measure in terms of blue of the simulated spectrum, that is the carbon dioxide atmosphere with no clouds. Next graph is the simulated spectrum, which is colored green, for a bare rock surface with no atmosphere, which is known as the ultramorphic rocks. And finally, we have the yellow graph, which shows the simulated spectrum, that is the thick carbon dioxide, that is its atmosphere with sulfuric acid clouds like Venus. And so looking at it, you can see that the curve is going in terms of the slope to be lower as you go from the blue to the green and to the yellow. But then the interesting measurement that is shown in terms of red, and in this particular description it says that the measurement in terms of the red diamond is consistent with a bare rocky surface with no atmosphere, that is the green line, or a very thin carbon dioxide atmosphere with no clouds, which is measured in blue, and finally a thick carbon dioxide rich atmosphere with sulfuric acid clouds similar to that of Venus, which is the yellow line, which is unlikely. So overall, I'm really trying to know what you think about this information about this rocky exoplanet and James Webb ability to detect this particular atmosphere of such rocky planet, and what is the future impact of this with regards to other exoplanets that are outside our own solar system and within not only our galaxy but outside our galaxy. So carbon dioxide, what do you think about this absence in this particular exoplanet? In the comment section down below, do you think there's any promise for all the exoplanets? We've checked TRAPPIST-1b, which has no atmosphere according to our previous video. Now TRAPPIST-1c, there is absence of carbon dioxide. Do you think there might be oxygen in there or not? Only more research and analysis will tell here. All the same, thanks for following me through this. Truly appreciate it. Hit the comment down below, let me hear your thoughts about this. By the way, we can talk to you soon. Stay smart as always and believe in yourselves.